Hello, everyone, and welcome. Thank you so much for joining us for today's webinar. I'm Hannah Jennings, a community organizer at Tech in Motion. As we get started, feel free to continue introducing yourself in the chat. Let us know where you're tuning in from, your current tech role, and what topics you're excited to hear our panelists discuss today. If you've attended a Tech in Motion event before, you know that our goal is really to bring together the tech community, to learn from industry leaders, make meaningful connections, and be inspired by innovation. Today, we'll be diving into a topic that is not just futuristic, it's happening now. Autonomous systems are transforming industries, workflows, and innovation across the board. Over the next hour, our expert panelists will explore cutting-edge developments in AI-driven automation, sensor technology, digital twins, and more. You'll hear what's coming next and how you can stay ahead. We'll also touch on hiring and talent trends shaping this space. And speaking of that, Tech in Motion regularly surveys our community to better understand the evolving tech landscape. Our founders at Motion Recruitment have compiled those insights and more into a new resource, the Tech Hiring and Job Market Trends Mid-Year Report. So whether you're building out your team or planning your next career move, this report breaks down what's driving the job market today and what you can do to stay ahead in the next coming months. We'll drop a link, and you should also see a pop-up on your screen, so you can download that after today's event. Also, be sure to stay tuned until the very end of today's webinar for live Q&A with our panelists. They'll do their best to get to as many as possible, so go ahead and start popping those questions in the Q&A tab. The session is also being recorded, so if you have to hop off early, no problem. You'll get a recording to your email after today's webinar. Before we dive into the panel, I am thrilled to welcome to you Nick Costello from our founders at Motion Recruitment. He's going to share a few key insights on hiring trends and the talent landscape shaping autonomous systems today. So welcome, Nick. I'll let you take it from here.
Hey, everyone. I'm Nick Costello, and I'm the Managing Director of Embedded and Robotics Staffing here at Motion Recruitment. We are also the founders of Tech in Motion, so I wanted to take a quick second and introduce myself and Motion. Motion Recruitment, we're one of the largest IT staffing firms in North America, and we specialize in direct hire, contract to hire, and project-based deliverable staffing. We have offices in cities all across the United States and Canada, and we have over 50 highly specialized technical recruiting teams that focus exclusively on specific tech disciplines in those local markets. Some of those tech focuses, to name a few, are software development, DevOps, cybersecurity, AI, machine learning, and embedded and robotic staffing, just to name a few. And as someone who has been matchmaking tech workers with companies over the past 8 years, I'm proud to have helped members of our tech industry take the next step in their careers and also help companies navigate hiring in a very competitive tech recruiting market. So if anyone has any questions about how to hire for your team and also just how to set yourself up for success in today's job market, feel free to drop those questions in the chat. I'll be checking in and responding throughout today's webinar. And for today's topic, the autonomous systems sector has seen a huge surge of popularity and demand over the past few years. And, over the next decade, the market size is forecasted to just have tremendous growth, and the technology advancements that are coming will allow us to create and achieve incredible innovation. So with that being said, I'm excited to hand things off to our panel of experts. And, they're going to talk more about what's happening in this space, how businesses are using these advancements, what is most in demand in this space, and what the future looks like it. And so that's pretty much it. And I'll pass it over back to you guys.
Great. Thank you so much, Nick, for those insights. Nick will be available in the chat. If you have any questions, feel free to throw them in there. Now, let's kick off our panel discussion. I'm excited to introduce our host, Ward Broom, a seasoned executive with a strong background in high-tech startups. After successfully exiting healthcare tech company, he founded IPA in 2014. Ward shifted his focus to investing in and advising early-stage companies. He now serves as a lead catalyst at Georgia Tech's ATDC, where he helps robotics and deep tech startups grow their product market fit, fundraising, and scaling support. So welcome, Ward. We're excited to have you host our conversation, and I'll let you take it away from here.
Thanks, Hannah. I appreciate the opportunity for being here, and I'm here in Atlanta at Georgia Tech, as Hannah had mentioned, and the Advanced Technology Development Center, just so everybody knows, is actually one of the oldest technology incubators in the nation. And my role here as a catalyst, I focus in the area of robotics and automation and deep tech. We're very involved in the robotics community, especially in the state of Georgia. And we've also formed an organization called Robo Georgia, which is a robotics hub, very similar to, or we're trying to be similar to Mass Robotics in Boston, which many of you are probably familiar with, and have worked closely with them to help us get our robotics hub started down here in the Southeast. We also work with the Pittsburgh Robotics Network. But excited about the discussion today and the opportunity to lead this. Autonomy and autonomous systems, as everyone knows, are very prevalent today, very top of mind. And we've got a really excellent panel that can speak to these, speak to autonomy and many of the different aspects of autonomous systems. So why don't we get into the discussion? And to start with, let's just have each of the panelists introduce themselves. Aditya, if you would like to start, that would be great.
Yeah, of course. Thanks, Ward. Hello, everyone. Nice to meet you all. My name is Aditya Srikumar. I am a senior manager at Symbotic, based in the Boston area. Symbotic develops automation solutions for the warehouse. And my role in the company is leading a team which develops software which goes on one of our robots called the Minibot. Joined Symbotic a couple of months ago. Prior to that, I was in the autonomous vehicle industry for 7 years, and in the IoT space prior to that. I also am involved with Mass Challenge for the past 5 years, supporting various startups and the Mass Challenge themselves in various stages of the startup's life cycle through that program. Primarily focused on robotics and consumer devices. Professionally, I've spent most of my career at the intersection of hardware and software and taking ideas into production in the real world. Great to meet you.
Excellent. Very good. Tyson?
Sure thing. Thanks, Ward. So I'm Tyson Phillips. I am the R&D Senior Manager at Piaggio Fast Forward. We're a smallish, about 80 people, consumer and commercial robotics company, hardware, software, everything from the ground up. And my team is responsible for the human-robot interaction side of things. So I do a lot of studies on human interaction, human behavior, and how to integrate those types of sort of situational awareness and interactions into our products. I'm actually an architect by trade. I do not have a robotics background, but I came in sort of via the exploration of humans as they move through their environments and trying to integrate that into our robotic systems. And I'm very excited to be here.
Excellent. Excellent. Brian, you want to go next?
Sure. I'm Brian Geisel, CEO of Geisel Software. We're a software development group that focuses especially on robotics. We say sometimes the robots don't have to move. And really just on the software side, everything from AI, machine learning, computer vision that we see a lot in the robotic space to motion and all those kinds of things are robotics. And I think we're seeing a lot of other things in autonomous systems today that maybe we wouldn't qualify necessarily as robotics. And then also we've spun out this company Simage, which is synthetic data, which I'm sure we'll talk about a little bit. And that had just kind of led us from where the tech is moving to the draw for people for synthetic data for helping train models better. So looking forward to this panel. There's some awesome speakers here.
Very good. And Ingen?
Thank you, Ward. Hello, everyone. I'm Engin Anıl. I'm currently based in Chicago. I've been a technology leader in autonomous driving and AI for over a decade, originally a PhD from Carnegie Mellon in Pittsburgh. I have worked at several startups and large companies in the space, including Here Technologies, Toyota Research Institute, Gatic AI, and lately at Grainger, a Fortune 500 company. Wide breadth of experience across the board. I have founded companies myself as well, and I've advised a number of early and growth stage startups in the space for the past couple of years, specifically on fundraising, technology roadmap, early stage execution. I am particularly passionate about bringing AI and autonomous systems into real world cases. I'm also involved with local tech hubs and initiatives as well in the Chicago area. And if you like to reach out and chat about any of these topics, you're more than welcome to reach out. I'm always looking to make more connections.
Excellent. Thanks, Engin. Well, thanks, everybody. And so why don't we kind of get things rolling? Kind of a basic question, if someone would like to take a stab at this, is, somebody define autonomous systems. There's a lot of things going on in the industry, a lot of different perceptions about autonomy. So maybe if somebody could take a stab at defining autonomous systems to start with.
Maybe I'll just slip in, a couple sentences
Sure.
about it. I'm curious how the others are feeling about it too.
Yeah.
To me, the autonomy or automation is a hardware, software, or AI system, or a combination thereof that is built to either replace or as a metric multiplier for a primarily a human-centered process. Could be around some kind of software automation. For example, Brian was mentioning data pipeline automation, like that. That is one example of it. The other one could be more around hardware and automating an industrial process.
Excellent. Anybody else want to take a stab at that? That was a kind of pretty all-encompassing. So that was excellent. And then kind of going further with that, then why don't we, if you guys can provide some examples, some industry examples of how autonomous systems are having an impact, where they're really having impact, thinking about robotics, logistics, manufacturing, software, maybe provide some examples.
Yeah, I think for me, when we consider autonomous systems, and you're kind of going off what Engin said, right? I think over time, we've had automation in the past, right? I think ever since, we started, factories and automation over there. I think what's changing in recent years have been the kind of convergence of at what degree of autonomy systems are capable of. This is a mix of, on the algorithmic side, things improving. But at the same time, when you consider a system with hardware, it's the hardware capabilities, both in terms of sensing modalities and compute, in being able to come together to do things which were not possible 10 years ago. And definitely in the warehouse automation space and the autonomous vehicle space, the cost to value has definitely improved a lot over time. And you can get a lot more automation for focused tasks in the warehouse setting, for example, to deal with packages for large items and small items. So definitely, I think you're seeing a lot of impact in structured environments. Very good.
Engin, did you want to add to that?
Yeah, maybe building off of and maybe it's taking it slightly on a tangent. Aditya said highlight a couple of interesting things, especially around structured environments or not. The way I think about automation in structured environments in warehouses, logistics, and so on, actually, I think what we have learned as an industry is that, this is some hard truth I had to learn myself, is the consumers of automation, they don't really care all that much about automation itself, and their metrics are really in cost, reliability, uptime, speed, safety, and so on. And automation is really the force multiplier or a multiplier for these metrics, right? So I think we have really started to converge these two perspectives. Hey, we want to automate, and we want better reliability, cost, and effectiveness. I really started converging these two perspectives in the last couple of years. And we have really started seeing the impact of that, especially in manufacturing and logistics, and as Aditya was mentioning, in warehouse robotics.
Yeah.
And I think I like, you said structured environments. And I think some of the things we're hearing from customers is that they don't believe they're a structured environment. So talking to warehouses that are not implementing as many autonomous systems as we think they ought to be. And they say, it's because I got crap all over my floor. So you think you're coming into this perfect warehouse, that you're just going to follow this perfect path and everything's going to be happy. And they're like, I've got crap everywhere. There's just garbage laying on the floor. I had a friend who was physically driving a forklift that ran over one of those metal straps that goes around pallets, and it cut one of the hydraulic lines or whatever it is, the brake system in the forklift. And so he's got this giant forklift going with a load on it that he has to decide how to best crash into the shelving system on the warehouse to not take out the rest of the warehouse. And he's like, how does an autonomous system solve that problem when its brake lines get cut because it ran over some garbage on the floor? And so I think that's one of the things that is sort of new as we've started to deploy more autonomous systems, is going to the real world. In the real world, stuff is messy, it's dirty, it's full of all sorts of issues that you didn't anticipate. And now we're starting to, I think, just see these sparks of autonomy that can actually in live go, okay, nobody told me what to do if my brake system got cut, but let me come up with a plan and let me think of what the best thing to do is. We're starting to see that level of autonomy, which I think is really interesting in these places.
Yeah, exactly. And why? Well, I'm sorry. Go ahead.
Oh, I was just going to say I would double down on that. That's a lot of what my team is doing. That's a lot of what we're interested in, is how we move beyond complete control and into generalized environments. Robots that begin to work alongside people. People are very unpredictable, probably one of the more unpredictable components of an environment. So as we're gaining compute power and sensor capability and all this kind of stuff, we're seeing robots begin to drop into these places. And that's one of the things that my team is very, very interested in. And we're going to get into it, I'm sure, but AI is a huge component of that.
Absolutely. Yeah. And Brian, your point, in regards to the warehouses, thinking about that, technology is great and it seems great. And everybody who's developing that in the lab is like, wow, why don't you use this? But in reality, there's got to be a reason to be using a return on investment, if you will, in the industry. So are there any industries right now that are actually demonstrating return on investment with autonomous systems? And if there are, maybe provide a few examples. Somebody wants to jump in on that. Ingen?
Yeah, maybe I will just repeat some of what has already been said, just by the volume and the type of operations. And as Brian pointed out, the fact that we are able to redesign and rethink some of the more traditional operations around robot capabilities. I think warehousing, robotics, and manufacturing are definitely at the top where the ROI is at with our current level of technology that's available in the market, and the fact that it's also a structured environment. And there are plenty of examples, like from autonomous forklifts to managing large inventories. For example, Amazon just release that they have deployed their millionth robot, and now they're starting to rethink what the next stage would look like, right? So we are really seeing true automation in some of these areas.
Yeah, absolutely.
And I think the interesting ROI for me is that we think about, again, like, okay, this company is doing this thing. What's their ROI when they do it differently by using autonomous systems? But what about the cases where the company didn't exist before? And so there's enough ROI for a company to exist, or maybe to exist in the US where we had to manufacture something elsewhere, but now we can do it here using enough autonomous systems. And I think one of my favorite examples for this was a logistics company where they're reaching out to truck drivers and they'll either email them and say, look, we think you have the perfect truck to do the delivery that I need. And these guys are driving, they're not answering emails. And so they set up agents to call the truck drivers and say, hey, I've got this load for you. And the truck driver goes, yep, sounds good to me. I'll pick it up tomorrow. Previously, they couldn't employ a human to do that because the cost was just, there was no ROI for them to do it at all. So they just weren't doing it. It's not like they were replacing a human to do it. They just weren't doing it. But as soon as they use an agent to make the phone calls and plug that in, now all of a sudden they're able to complete way more deliveries and to do them at lower cost and all this kind of stuff because they can get the right truck drivers. So I think there's an interesting play there also for places where we aren't solving problems today, or maybe we wanted to and we couldn't with humans, where they're not even replacing humans, but they're a brand new thing that we're able to do with autonomy.
Yep.
Reimagining or imagining new businesses with the technology that's available to us.
Yeah.
Yeah, I think there are things we don't know. So as we get into this, there's going to be some amazing applications, I think, that we're going to learn. One of the applications I think is amazing is in agriculture, and especially with the labor challenges in agriculture. Does anybody here have experience in the agricultural area with implementing systems or real applications?
We did some work there with a company that was actually growing crops in the desert in Dubai. And so really the autonomous system is the entirety of the, I don't know that you'd necessarily call it a greenhouse, right? But like the hydroponics that they were setting up and water reuse and all this stuff, and then determining the right time to feed the plants and that kind of thing. So a little bit different than like some of the autonomous systems that are in fields and stuff, which is amazing also.
Yeah.
But then also growing stuff in places where we couldn't previously grow it, that kind of stuff, which is pretty interesting.
Got it. Yeah, and when you're thinking about warehousing and logistics applications, where you guys are very focused in those areas, how do you, when you talk to your customers, how do you speak about ROI?
Yeah, that's a great question, right? And I think everybody I think Engin hit the nail on the head, right? Which is when you balance, the cost, safety, utility, is there enough ROI on how much you're spending to the utility? And that's, our systems are not, in terms of we can do this capability autonomously as a feature, right? The feature is really, we can operate on these many cases or these many units per hour, improving efficiency, optimizing storage, right? In a warehouse, like space is also a constraint. And so we can efficiently utilize space to provide a lot more throughput on the cases coming in to the cases going out, where that's actually the value proposition, right? And so the business case has to support the technology going into, because there might be scenarios where it's not worth the cost to automate, and you continue down the human path study, right? With the cost overheads everybody has. So there has to be the ROI for the customer on what their primary business goal is and what we deliver. And so that's been the focus. I've been here for 2 months, but that's all, since the day I joined, that's the focus, right? What are we focusing on from the system as a whole?
Got it. And do you think that if the labor issues were not there, and let's talk specifically warehousing and logistics, or really in any application, if there were no labor issues, so you could get as many people as you needed to do the job that you needed, would there still be a return on investment with putting in, because committing to these systems is a big decision for a lot of these companies?
Yeah, definitely. I think even in my view on this, right, even if you have the labor to support it, the ROI is also on the throughput of these systems, right? How many cases an hour can the system get through, right? Because when I go to one of our sites and I see the bot zipping past me with multiple packages going in and out, you see there's also the quality with which you're kind of getting these systems out with the lower error rates, as well as the mere throughput. And I think there's still a case to be made as that isn't. But definitely, the labor costs are also a factor in the cost, right? So I think there continues to be a case even with labor workforce to support it. And and then you kind of get into the synergy of humans working with robots versus like an either-or system, right? Like how can you supplement to a human workforce with the automated workforce along with it?
Got it.
Yeah, I think the trick to that is really in the fleet management, right? The ability for the robotic system or the autonomous system to know everything that's going on at all points in time from a central perspective. And if you put 1,000 humans in a warehouse, all of those are individual humans and they have no central source. You can provide information, but there's not like a sort of central mind. And at least for those larger systems, they really benefit from this sort of like central control of the entire fleet.
Yeah.
Maybe just like to add another flavor to that is usually my experience in human-centric systems, we build several layers of redundancies to make sure that for example, using Aditya's example of moving boxes through a distribution center, right? Like what goes in a box and what comes out of the box will be probably counted multiple times to make sure that the counts are right. Right, so even in those cases, like being able to take out the redundancy and like being able to centralize it with high accuracy is valuable, even if you have the infinite human to do the job.
Got it. Very good. So with that, thinking about that in the ROI, the need, labor issues, people have to put in these systems, then what are the barriers that you guys are seeing out there for deploying more autonomous systems? Why are more people not moving immediately into this?
Yeah, so for me, there's a reason I kind of called out structured environments in the beginning on ROI, right? Because Brian accurately pointed out, like structured environments aren't perfect, but they're still bounded in some degrees, right? Which is you're still operating within a specific, either geographical domain or some constraint, and the capabilities today allow us to make decisions even when it's not perfect within those structured environments. And I think one of the challenges I'm seeing in autonomous systems at scale is really what we conventionally would call an unstructured environment. And Tyson covered this as well briefly, right? And I'm sure we'll talk more about it. But in unstructured environments, like how do you balance this, the utility of what your system's providing to the cost and safety and engineering development required for it, right? Because if you're going to solve a general problem, what cost is that coming under and what is the utility, right? And I think over time, it'll come down in terms of some of those metrics. But for me, I think that's one of the challenges and items we still need to work around and figure out what are the real solutions we need to deploy in those environments.
Got it. Anybody else want to comment on that?
Maybe I'll jump in. Like when I think more at a high level, one, as your question was, why don't we have more robots or automation systems? Like I think 3 buckets of challenges. One is around who is buying these technologies, who is the consumer. And for most of the robotic solutions or automation solutions, your biggest customers will be your legacy corporations who have built very complicated, set in stone operations in a very specific way. And getting into that place, getting the approval and buy-in and fitting into these operations and exactly how they require, and like perhaps building out piece by piece, that is going to take time and it will be hard. And the solution you build for one customer, I guarantee it will not work for the other customer. That being said, in the past 10 years or 15 years in the great graveyard of robotics companies, these big players have also learned how to work with robotics players, and they have been learning how not to treat your robotics vendors as your IT vendors from 1999, right? So really good learnings on the corporate end of this, which is good. And that's a challenge we are overcoming now. The other one is who is building and selling and operating these robots, right? For example, a technical founder coming out of grad school, let's take an extreme example, that they will build a robot. Like there's no doubt in my mind that coming out of a top school or having built something before, will be able to build a robot. But getting from, let's say, 1 to 5 is a different problem from getting 5 to 5,000. 1 to 5, you just do the same thing 5 times and you'll be fine. 5 to 5,000, you have to reimagine as a robotics company how you operate, how you think about your internal operations, your engineering, how you build and serve and maintain these systems. So most companies, in my experience, most robotic companies usually fail at that stage and fail to scale up. And the other one is, someone pointed out this before, shifting the narrative around the purpose of automation. I don't believe the purpose of automation is to replace humans. And I believe we need to start reimagining the roles and jobs around automation and leverage human skills in ways that we have not been able to before in the presence of these technologies. And I think, like, the intersection of these three things, if we the more we can figure out that intersection space, I think the more we can successfully scale up.
Got it.
Yeah. And I think there's a piece around just that maybe not related to automation really in any way around customer, which is some of the things we're hearing from customers are like, yeah, these vendors keep coming to me and going, here's what I've decided that you need. And they're like, well, that's not what I need.
Yep.
And I think we can do that more so in the technology space because we get excited about the tech and we're like, look at this problem I can solve. And we don't necessarily bother to ask if anyone would like to have this problem solved or if it's a problem that they have. And we're like, I did it. And early robotics was 100% that. And then we've transitioned to learning how to work with customers more. But I think that's still a huge issue in the industry overall, is just we're not spending enough time with customers going, what is your problem? And we're going, why aren't you adopting these systems? And I think we need to be asking more questions as an industry of the customers.
Yeah, no, great points. Really great points. What about on the regulatory side? Are there any type of regulatory barriers to people implementing autonomous systems at this point, or safety issues that they have concerns with?
Yeah, well, a lot of, especially on the autonomous driving side, some brave companies are going out there and trying to operate on public roads, which is a very different problem from trying to operate in private yards or private roads or structured warehouses and so on. And I think that's part of the building off of Aditya's earlier points, being able to find these problem spaces where we can both constrain the problem to the technology, not the other way around, and also finding these applications where you don't have to honestly deal as much with regulations and being able to control your environment. I think that's where a lot of very interesting work is happening and will continue to happen.
Got it.
Yeah, safety is a huge topic of conversation in our company and everyone I've talked to that attempts to integrate robotics into their current workflow. That is the number one concern from a lot of our customers, especially because our robots are designed to work alongside people within a meter of them. These things, they weigh 120 pounds, which is not super heavy, but if it runs into you without sort of awareness, it can definitely do some damage. And where the amount of damage that can be done isn't all that high, death is not a huge concern. The consistency with which it happens is a concern, and the likelihood of its occurrence is a concern. So a lot of what my team is doing is we're attempting to understand humans as completely as we can and be able to predict what they're going to do in order to operate around humans. So as opposed to forcing robots into a space and seeing if the humans can adapt and sitting down with the humans and saying, hey, there's going to be robots in your space. Here's what you need to do to make sure you're out of their way. That we could actually learn what the humans are doing and have our robots respond intelligently. And that is a component of safety in our eyes.
Got it.
Yeah,
No,
and
that's a
if
great
you
point.
kind of take AGI aside, because I know that's a whole topic of conversation, right? But in these constrained systems, if you think about the integration of AI, as you're talking in specific to applications, and regulatory standards, and some of those standards were designed at a time when software was deterministic to some degree. Like you can clearly prove out yes or no what's going to happen at the end of this. a lot of them is definitely not for probabilistic models of software, which we operate on with sensing modalities nowadays. And so for a lot of companies, and including in the autonomous vehicle space and even in constrained environments, there are teams trying to actively figure out like what should be the regulatory space, like what should we be doing in conjunction with regulators and what these standards are supposed to be. And there's I think there's a lot of debate. I would call it healthy debate, where we need to come to an outcome. But the standards the standards of the past are not going to work for the systems we have with the technological advancements we've had in the last 10 years.
Yeah.
100%.
Do you feel like that when we talk about safety and regulatory concerns or regulatory needs, is that a barrier in thinking about, the U.S. versus other countries? Is that going to be a barrier for the U.S. to stay in the lead, or, I don't even know if we are in the lead in many areas, but is that going to be a barrier for the United States to continue to move forward with autonomous systems versus other countries that may not, have as much of a concern and may be able to jump ahead and experiment and fail and move forward?
I think my view on that is really on scale. And we talked about what prevents deployment, right? I think development continues to happen without public deployment. But yes, definitely on the deployment to scale, like what Ingen was talking about, it is something which depends on who you compare to. Like compared to some parts of the world, the US is much more liberal in its legislation. In other parts, it's much more conservative. But I think research can continue to happen, but the deployment, like we talked about, right? What stops deployment at scale is really going to be what is going to lag behind unless we kind of solve those problems soon.
Aditya, would you agree? Like, in addition to being able to deploy or not, that's also like tied to, let's say you're taking an end-to-end approach to your robotic system as opposed to a classical approach. You need data, and to get data, you can simulate, but simulation will have limits. And in my opinion, you really need to get out there and put your vehicles or robots out there, get real-world data, and start working through the real examples. Would you agree that like it's also regulations can also be a barrier to really putting that aspect of training and development as well?
Yeah, it can slow it down. I don't think it would block, right? Because if you consider autonomous vehicles early on and until more recently, right, you always had safety backup for a lot of the vehicles on the roads. Like up until, I don't know, a few years ago, almost all the major AV players had safety drivers, or whatever the version they call it is, at each company. So I think there's data collection. I think definitely now the home environments are a big one, right? Because you've got humanoid robots are ramping up in terms of the industry as a whole. They're coming up, and so it does present a different challenge than what autonomous vehicles have had to go through. But I feel the equivalent of kind of beta testing a product and getting data, I think would still be possible in our frameworks. But and that's my view on things.
Getting from beta to scale, like regulatory issues, can definitely be a problem there.
Gotcha. Very good. So let's kind of jump into technologies. And so what are the enabling technologies that are allowing this leap in autonomy and is going to take us to the next stage? What are some of the technologies that are out there right now that are leading us in that direction? Tyson, you want to take a stab at that?
Yeah, absolutely. I'm a huge fan of all the technology that's being driven towards edge computing. A lot of what we're seeing from, if I'm going to name names, NVIDIA, bringing their chips to a more powerful level, enabling us to receive more information on board our devices, and also run models or complex environments that allow us to make decisions on board models, will help bring these autonomous systems into more unstructured environments. I know we've talked a lot about unstructured environments. Certainly one of the current issues with unstructured environments is there's no cloud in a lot of places. If your robots are out in the park, if they're out in military zones, if they're out in Agriculture spaces, a lot of times, all they have is maybe a GPS link to a satellite. So by producing chips that allow them to do more compute on board, we're really going to see some big improvements in robots that go into unstructured environments.
Got it.
Yeah, and I think that's completely agree with what Tyson said, and I feel like on the other end almost is like the maturity which has come in recent past in like simulation platforms and digital twins have been instrumental, right? And Brian knows all about synthetic data now, right? But it reduces the barrier to entry to develop systems significantly. Your testing capabilities go from one bot for 100 people if it's expensive to everybody can run it natively. And there's also, even within simulation environments, like there's cost level, right? You can have a low res simulation, which is you can run it on your PC. You can have higher resolution, you can run with a GPU. You can have photorealistic ones you run on a cloud server. So the barrier to entry is reduced so much that you can sit at your home and already develop something which is pretty robust, which would have been very hard in the past.
Yeah, 100%. I think some of the things that we've seen in that realm, we ended up building a platform where NASA was having this problem where they said, look, everybody that runs their stuff in simulation runs in the simulator. So the simulators, whatever giant cloud compute they want to use, whatever it is. And NASA has the issue of swap, size, weight, and power. Because we care a lot when we ship stuff to space, how much it weighs to get up there. We have limited power, all these kinds of things. And so for them, trying to deal with this swap issue, the more things that we can, that we're able to simulate and get things like the NPUs from a hardware standpoint, right, to be able to run models locally and use less power, those kinds of things. But the other thing is to actually be able to simulate it on the chips. So we've sort of made it like this staged level where you can do everything 100% software simulation, or you can go, okay, this is the quad core ARM I'm using for 16 drones or something. So put actually 16 of those out, run the actual workloads on those, and you get closer to the real environment. You can actually see which ones break down or don't have enough compute or whatever. You can simulate the sensors in, you can simulate the visual in, and then you can start to swap out and go, okay, I'm going to run you in the real world, but I'm not going to blast my local town with radiation to test that part. I'm going to simulate the radiation and kind of swap in and out all of those parts. So it's like taking it beyond the digital twin or the simulation we've done in the past, to where you can take these stepping stones until all of a sudden you take the next step and it's almost like, oh, I'm running fully live. And that was just one small last step to get to the, sorry, I didn't mean to make the pun with, one small step. But getting to that point, right, all of a sudden we're operating in the real world now and nothing really changed from our last stage of simulation.
Got it. Any other comments on the simulation environment or how critical simulation is?
Yeah, maybe like the way I like we think about simulation, especially when building autonomous systems, is like in terms of testing and making sure that something is as safe as it can be before we put it out into the real world. And the way I think about testing and validation is almost like a pyramid, right? Starting at the bottom, you're like, test whatever, integration tests, all of that. And the last step before you take something out into the field and try under real conditions is simulation. And what we are able to do, like as Brian explained, like very aptly, what we are able to do in simulation is getting so much closer to the real world conditions that we can be a lot more certain that things will perform the way they are supposed to perform before we even set our foot in a truck or an autonomous vehicle or a forklift, which in my opinion is a game changer. Like especially from a financial perspective as well, for a company building these robots or automation systems. Operations are expensive. Getting out into the field is expensive. Building 10 of the same expensive truck is a lot of work and effort. Being able to break it down into pieces, simulating them under the conditions that they are required to operate, and then building up is a true game changer.
And to the point of how good simulations gotten, I don't know if they put the survey out to the audience yet or not, but one of us speakers is actually simulated.
It's you, Brian. It's you.
We all know it's you, Brian.
Yeah. So what about, let's get to talk about ethics a little bit. What about responsible autonomy? What does that look like? How important is that? And, when you look at real world deployments, how important is considering responsible autonomy?
I think it's incredibly important. I'm sort of broken record here, talking from the perspective of autonomous systems that work with people. I think we're all interested in autonomous systems that don't necessarily replace people, but augment them, enhance them, make their lives and their work better, safer, more enjoyable in a lot of ways. I'm a big proponent of attempting to code and understand, both in classical format and from a AI perspective, social awareness and social etiquette, which is something that we as humans have developed. Animals have developed it over millennia, and there are like rule sets which we sort of bring into our lives and our interactions, and I think that's a really interesting and very valuable thing to try to emulate. That's a specific example of what a responsible autonomy might be, is robots that are kind as you're walking down the sidewalk, that give way to each other and respond in culturally appropriate and socially appropriate ways.
So anytime you have autonomous systems, robots working in the same environment or close environment as humans are, what you're saying, Tyson, is that it's critical. It's something that has to be considered.
Yeah, I think it's to the benefit of the people who employ the systems and to the people who are actively interacting with the systems too. There are studies that show that proper interaction can actually improve the experience of a human working with a robot, whereas systems that are not designed for sort of appropriate interaction can be a hindrance to the human's experience in their environment. So I am a big fan of suggesting that robots that respond appropriately make everything a little bit more ethical and also more performative if you're going for ROI.
Sure. Okay.
Tyson, the number of robots we've put googly eyes onto would probably not blow your mind, but everyone else's mind, just because all of a sudden the humans are like, oh, I know which way is the front now.
Yep. I know Amazon's working with adding faces to their robots, or even systems that suggest as a kind of a user interface, like which direction they're about to go. Just having that little bit of feedback has been proven to be really effective. And googly eyes are like, how much are those? Like 50 cents?
Right.
Got it.
And I think it ties, it eventually, this ties into, if you think about it purely from like, an ROI perspective, right? This also ties into safety quite a bit, right? So everything Tyson said ties to like being able to safely interact with the bots, use it. And it's not obvious from like the pure utility. So autonomous vehicle is a great example, right? Like you start off, I think the first ones they had, they were a car and they used to drive by itself. But over time, there's been more interactions and communicating what the vehicle does to people outside the vehicle. And that eventually directly ties into safety as well over, as more research and more deployment happens. So I think they go hand in hand over time to develop that trust and, provable safety.
Yeah, absolutely. So we're getting a lot of questions, comments in regards to skills that companies need, training, that sort of thing. So what are some of the skill sets out there that are, non-negotiable skill sets for developing and deploying autonomous systems? Anybody want to take that one? Brian, do you want to comment on that one?
Well, I think one of the ones that's, newish, right, in the last 10 years or whatever, but just the machine learning aspect of things is growing in so many places that just understanding it, understanding what it is, it doesn't mean necessarily every single person needs to be able to build a model, but understanding how they work and how to interact with them, I think shows up in certainly a lot more jobs than it used to. So I think that's one small piece of just a way to educate yourself, or make sure, I don't know, if you're going through school or whatever, make sure you get a class on it, that aspect of things.
Got it.
Tyson covered this as one of the areas, right, in which is enabling technologies on edge computing, right? And for me, I feel that's a big one, right? Because there was a time when, all your ML models and stuff used to run in a purely software systems. You could have a CPU, you could have a massive computer, you could have a server which ran it. But inference is moving to the edge, right? So not training. So I think training continues to have a degree of influence on the cloud models and compute clusters. But inference at the edge is important for like deployment nowadays for a variety of reasons and use cases, from like cost to where the bots are going to get deployed. And so from a skill perspective, that is a skill which is not implicit, because it's kind of a mix of disciplines. Because, are you doing ML development, or are you doing, embedded system development, or are you doing bot development? And all of these come together when you talk about inference. And so I feel that's something which I've not seen it explicitly being called out. It's definitely a skill more companies are hiring for specialization, but I think it's also generally something everybody needs to ramp up on what it means to kind of deploy your model to a more resource constrained device.
So how do people, there's so much happening, there's so much technological development. How do engineers and developers, how do you stay up to speed on all these new technologies? Because everything just seems to be accelerating, and everybody has their regular jobs, regular issues, challenges they're dealing with every day. So how do you stay up to speed with that kind of thing? Can companies support their employees in some way?
I think one of the things for me that's like how I'm changing my own workflow and my own education is how much more I'm using LLMs for it. So one of the things I found LLMs great at is teaching to exactly me, because I went to college for 1 year and took the early retirement package. And so over my career, I found I had weird holes that I had to patch myself. I had to just go back and plug in bits of theory or whatever that I was missing. But now all of a sudden with the LLMs, I'm able to say, hey, I have this and I have this and I understand this, but I don't really know too much about this. Now, can you explain this concept to me? And the LLM will actually give me the bits that I'm missing along the way, and then give me the new technology. And so I think making sure, I'm answering a little bit of a different way, but I think making sure that you're educating yourself and doing those kinds of things, but there are tools now that are able to sort of help accelerate that, where you don't have to watch a whole bunch of classes that are stuff you already know to get to the stuff that you don't know, or miss one important piece in a class along the way. You can actually get stuff targeted exactly to the pieces that you need to learn.
Yeah. Well, part of your question was like, people are already busy. How do they stay current on the technology, and how do they, keep upskilling? One of the more practical ways I've been using AI is to actually on this, and like similar to what Brian describes. For example, I have very, very limited amount of time to write hands-on code, right? And it's mentally it's an expensive process to write good code. You have to sit down, you have to focus, you have to think about what you need to write. But I've been actually leveraging LLMs and these newer, fancier models to get me started on how I need to write it and how I need to structure it. And then build on top of it, knowing that I'm still responsible for the code, not the AI, and that's perhaps the responsible part of responsible AI. I've been finding a lot of utility in these newer tools just to use my time more effectively when I'm doing hands-on work.
Got it.
And Ward, what you said on how companies can help, right? And I think we're seeing more of an adoption of this, right? I think to me, it comes down to use the tools which you think are relevant. Because there are, I don't know, I feel like 2 years ago, there were a defined set of tools, like 2 or 3 you needed to do your job as a software engineer, and that was about it. Right? I don't know, Google Stack Overflow and a code editor, and you were pretty good to go get like a compiler. Nowadays, I feel like we've moved from this, single companies having the solutions to like tools specific to each purpose, right? So you have your development software, you have things for research, you have, designers have their tools. So I think trying to get hands-on time with the tools and just figure out if it works for you or not. And from a company perspective, I think companies have started and I think should invest in integrating that and giving access easier, because there are a lot of tools and not everybody's aware of what tools might be good. And so, if someone's done the research, I think companies should invest in having pilots for each of these tools internally, whether it's your AI code editors, whatever is your favorite now, or getting versions of AI integrated with your documentation processes internally. So, and I think that's where companies should invest in for everybody.
Yeah, I think with that, Aditya, especially for, let's say, robots and safety critical systems, I think an important part of the conversation for companies is to build guardrails for people to use AI in the right way and the responsible way as well. For example, as someone who have developed these kinds of systems, I wouldn't want AI to touch any like safety critical part of my software unless I have some transparency built around that. So I think that there are some important conversations to be had for those companies as well, both from an encouragement standpoint and also from a governance standpoint.
Excellent. Excellent. So we only have a few more minutes left here, and Hannah's probably going to be mad at me because I haven't gotten to a lot of the questions from the audience, but I think we've covered a lot of the questions as well. But, one of the questions, someone is asking us to speak to autonomous vehicles and humanoids. Okay, so does anybody want to make a comment on? Let's stick with humanoids, which again, humanoids. It depends on what day of the week you're talking about that. But where do you see with humanoids they're here to stay. It seems like, but where are we really in the implementation of humanoids? When you think about people's homes, when you think about industry, are we really there? Is the technology really there? Can they, can they be safe? Who wants to take that? Just your comments on that.
I might tend to this question.
Go ahead, Tyson.
Okay. I was just I might tend to this question as a bit of a skeptic. I feel like humanoids are a little bit egocentric, and it's a little bit of a pipe dream to build robots in our own image. But I do think there's some very interesting problems. And as we're addressing humanoid robotics, all the problems that we come across are very interesting and can be applied across the world of robotics. I think from a safety perspective, probably one of the more interesting things is pretty much every robotic system that is actively working in environments, especially with people, their default safety method is to shut off, turn off, hit the brakes, stop moving completely. And if a humanoid does that, then it falls over, and it could fall on your child, it could fall on your dog, or it could fall, on something that's very expensive. And so safety is one of the things that I think is going to hinder humanoid deployment for a really long time.
Got it.
I'm going on the other end of this, right? And so this is maybe in opposition to what I first said on utility, right? But I feel the industry has made a lot of progress somewhat randomly, right? Because you kind of had this general problem you were solving, and then you realize you can apply it to actual utilitarian tasks along the way. And I feel like humanoids are a great example of the heights of kind of unstructured, right? It maps to what we do. So from an environmental perspective, they should theoretically be the most adaptive to operate in the world we are today for any task, right? So if humanoids can operate as humans do, then you've effectively automated everything. And so as a goal, I think it's a good path to go down to kind of develop technologies Towards it, I remember like I think I worked on humanizing grad school like 10 or 15 years back, and it's back now, and it's looking very different than what it did back then, but we're still solving somewhat of the same problems. So I think it's good to invest in. It becomes a cost to utility ratio for me, right? Like I think scaling will be more cost effective for solutions in robotics which cater to the problem you're trying to solve, rather than try to put a humanoid in place to solve that. So and that's my view.
Yeah, no, good point.
Yeah,
Anybody else want to take a stab? Brian?
I think humanoids are stupid.
Tell me what you really feel, Brian.
Yeah, I'm holding back for the panel here, so I'm filtering it a bit. But no, I mean, think about it. Like how much less creative could we get? Then let's solve the problem again the same way we solved it after we, finish eating dinner. So think about robotic vacuums. Why would I need a 6-foot tall tail on the back of my vacuum that means I can't get underneath anything? And why would I want to carry around 50 kilos of mass to push the robotic vacuum around? Why don't I just make a vacuum that's way more efficient, that is exactly where the dirt is, that only needs battery life of the task that it needs to do, and just create the thing to solve the actual task, and instead of like reimagine the task, instead of looking like, how do I do the task today? And then let's deploy all these crazy resources to do it, just like, this biped bag of water does it.
Ian, did you want to jump in on this?
Maybe I'll take I actually agree with a lot of what Brian said. I'm not going to say humanoids are stupid, but I'm going to say they haven't really found their like real use cases just yet. However, I think what's going to happen is with all the development resources we are putting into it, like controlling and actuating a humanoid is extremely hard, right? And I believe some of the technologies that will come out of the humanoids will be extremely useful in other places in like more shorter term before we hit the point that Aditya wants to go. I'm actually excited about that, just seeing what kind of stuff will come out of it and in what ways we can really start integrating them into more realistic use cases in the near term.
Yeah.
And the cost has come down, right? Like if I think about it, like 10, 15 years ago, the cost was 10 times more than what it is today. And you can buy a humanoid for like, I don't know, 15,000, 20,000, which would have been crazy 10 years ago.
Yeah. Yeah. And then I just saw yesterday, and I can't remember the name of the company, where they have an open source platform. You can build it yourself, $299 or $49 in your home. So I think that's really going to be interesting to see where that goes. So, well, listen, thanks so much, everybody. This was really great. Any last, give you guys a chance, any last comments you would like to make before Hannah comes in here and shuts me off? So, but yeah, really appreciate y'all's input. But yeah, I'll just give you guys a second. Any last comments or parting comments you might have?
Great discussion. I'm glad we, and I think Brian called it out when we first had this. Like, I think we have things we don't completely agree on, things we're on the same page. But that's kind of the interesting part about robotics, right? Which is like there's so many avenues of development and research going down that we're not at the production or scale yet. And that's going to be the next 10 years where we actually see the applications grow.
Yeah.
I think for me, my parting thoughts are reality failed us for the last time. And I think we're able to get to so many of the edge cases. I think computer vision has come so far to helping us with autonomy in so many different places. Now with synthetic data, how we're able to get to test things we couldn't test before, or train models for computer vision we couldn't train before. And then I think on the other side of things that's taking us so broadly is like, and we didn't dive totally into it, but the agentic stuff, where we have LLMs that are user interfaces for humans. So all of a sudden a human can actually just say to the robot, can you please go vacuum the living room, or please go save that baby from under that bus, or whatever. And then it can go execute on it, to also the things we couldn't solve before because the space is unbounded to where an agentic piece of that workflow might be able to go, oh, I have this aspect from this robot, this aspect of this robot, and I can put them together in a way that the programmer never envisioned in the first place. And now we can solve a set of problems we haven't even come to yet. So I think there's so much stuff coming in robotics and in autonomy in the very near term.
Yep. Would agree. Would agree. Very good.
Awesome. Well, thank you all so much for that deep dive on autonomous systems. And thank you all in the audience for your awesome questions and being so engaged in the chat. A special thank you to our panelists for sharing their expertise and perspectives on this very exciting field. If you guys have any feedback on today's event, please click the survey link in the chat and on your screen. It helps us continue to make our events better in the future. Thanks again for joining, and we hope to see you again at a Tech in Motion event very soon.
Thanks, Hannah.
Thank
Thanks, folks.
you.
Simulation shutting down.